Anything, any
No.
practice at all?
I don't know of any real
Do
industry-wide
you have a practice yourself, though, Dan?
standard, but I have a practice that my journeyman taught me back when I was an apprentice.
Let's hear it.
Was that all the wires coming back from your start buttons need to be bright colors, and all the ones coming back from the stop would be the bright colors. So all the ones headed for terminal 2, and then all the ones from the start buttons would be the duller colors, like a brown. So you'd have like an orange wire coming from your stop and a brown coming from your start.
Right here. Stops would be what color?
Would be the brighter colors. So it'd be like a red, orange.
Okay. And then these, the twos would be what?
Would all be the bright color, and then
All bright colors.
the threes would all be the duller color.
Okay. All right. All right. That's just the system, right? All right. 3-wire control circuits. Another 3-wire control circuit. You got to be. Oh, good. At least it's supplied by a transformer. Something different. Don't tell me you don't know 3-wire control circuits by now. Control transformers are frequently used in motor controls to provide greater safety to personnel by using reduced control voltage. All right, let's see what we got here. All right, we got a 480-volt system. Line 1, 2, 3 coming in, main contacts in the motor, da-da-da-da-da-da-da, T1, 2, 3 going to the motor. These are my overloads. All right, I want to operate a 120-volt control circuit, so I put a transformer. Now, do I put a transformer, or do I just buy a starter that has a transformer and the primary is already pre-wired with the fuse protection?
Yeah.
Is that the way it is?
Yeah.
Okay, let's talk about the way it really is most of the time. Steve?
Depends on your application. You may be picking up your control circuit from some other remote place like an air handler.
No. I'm saying off a transformer.
Yeah, but the control circuit may be in a transformer in another piece of equipment that is going to control your starter if you're interlinking systems.
But is the transformer there?
Could be.
Is it already pre-wired? The primary? And you just have the terminals for the secondary?
Um,
How often do you go, would you buy a transformer and put a transformer 480 to cut it down to 120 for your control wiring?
Well, if you're starting from scratch, you're going to try and get it in the bucket with a starter. If you're designing it,
That's what we're talking about.
Yeah, if you're
Talking
able
about
to
today, a
design
guy
from
going out
scratch.
today, if you're going to have a 120-volt control with a 480-volt starter, is the Dan?
In the, you'd have to know your control scheme before you buy your MCC.
Yeah.
So
Right.
if you wanted to use that in your control scheme, you would order them in the MCC.
All right, so the practice would be you need to understand your equipment. And if you
Yeah.
want to operate 120-volt controls and you got a 40-volt contactor, or a starter, rather, you're going to make sure your starter comes with a transformer already pre-wired. And you're just going to come off the 120-volt terminals of X1, X2. Am I right about that?
Yes.
Okay, so therefore we will show all this in black on the primary with the fuses because that's going to be by the manufacturer. The X2 would be in black because that's also by the manufacturer taking care of that side of the circuit. And then we just go back to our standard. Now, I don't understand this. We're going to talk about this tomorrow, but I don't think there's any fuse protection on the secondary, is there?
There's normally one.
There is fuse protection on the secondary,
Yes.
as well as fuse protection on the primary?
Yes.
Huh. All right, we'll talk about that in the next DVD. All right, so we're just saying that you're able to drop down lower voltages. The best thing is get your equipment with a transformer already pre-installed. And what do we got here? Here's a different way of looking at it. Here's my line 1, line 2, primary side. I'm going to have that in black. Here is my X2 going over to the M coil. We'll have that in black because that's already done by the manufacturer. Are the fuses, if you buy one, are the fuses already there? The primary fuses and the secondary fuses?
Yes.
All right, so that'll all be black. The primary, secondary coil and the fuses will be black because that's there. I'm just coming off of X1, going over to my stop in series with my start, which is in parallel with the auxiliary contact, and I'm just going to be running my 2-wire, my 3-wire, and my 1-wire. Right? So
Yes.
whether it's 480 to 120, it's not that big of a deal. It's still the same basic 3-wire control circuit. All right, 3-wire control circuit with a neutral Well, it's 120 volts, so it is a neutral. I mean, using that example, again, we'll have this already color coded, so they're all black, whatever it's not, it's all by whatever's pre-wired. And the neutral conductor comes off of L2, which is connected to the coil. Now, the code actually says that you cannot use a neutral conductor for any kind of control. And the reason being is because if we took the hot wire and we connected a hot wire to, let's say, the one side of the coil, and then we use a neutral conductor to the other side for the control, if there was a short of the neutral conductor to one of the other wires, you could bypass all the safety protection of a 3-wire control circuit by bypassing all that, and then, of course, the coil could be energized, the motor could run. But I got to ask you a practical question, whether this is just a waste, whether this is a great theoretical concept, you don't use a neutral for control. Isn't it already, watch this, if this is black on the primary, because that's manufacturer, if the transformer secondary is black as a manufacturer, if the secondary neutral with the overloads is black as it's a manufacturer, if the X1 to the fuse is black with the manufacturer, then isn't it a no-brainer that you're not going to be using the neutral for the control circuit? There's no way to physically do it, just the way you buy the starter?
Right. What happens a lot of times is if you have a starter bucket, sometimes it's called that, with everything included, then the field wiring is attached to a terminal strip or barrier strip that's in the manufactured product.
Right.
And so you're only going to be connecting external wiring to the barrier strip in the equipment.
Right. All right, but let's just review this again. If you somehow use your neutral portion, because the neutral is going to be grounded here, if you use a neutral as part of your control wiring, you could have a fault to the neutral to another conductor that could bypass the start button, and it could cause the motor to start and run, and you have no way to stop it, no way to control it. One of the things I want to talk about in the next DVD is safety. Have you guys ever heard of an experience where you had a failure of a neutral that caused a restarting of a motor or a running of a motor? Anybody?
No, because we don't wire them that way.
Well, there you go. Okay. Simply solves that problem. All right. Option of using a 2 or 3 wire circuits in one diagram. It's common to have a line or a connection diagram that shows connection points for both 2-wire and 3-wire circuits. No, not another 3-wire circuit. Okay, so here's my connection diagram. And, okay, it's showing a dotted line that here's the option. If you want to, you can use a start-stop between points 1 and 3. Or don't use a start-stop. Optionally, put a 2-wire control circuit. That's what we're trying to do. Go from line 1 to line 3. That coil is going to operate. And let's see. This line 2 is going to be black because that's already pre-wired. All right. And then here's your 2-wire control circuit, 1 to 3, 1 to 3. Here's the start-stop. That's fine. And I think this is just showing what it would look like, the wiring diagram inside the actual contactor itself. On the diagram given on that. Now, Dennis, we got something over there at the end of that table. What's
Well, and this is what Eric brought was basically an MCC bucket, and we were kind of hoping that there was a transformer in there, but there's not one in there. But Eric's got a transformer, I think, in front of him that would physically go inside this bucket.
But wouldn't you have to get equipment that is designed to use a specific transformer by that manufacturer and to be installed in that equipment?
Yes.
You can't now start going
Right.
in and dropping transformers in there. In other words, the step-down voltage is part of a whole package that you're going to be getting if you're going to be doing that.
Well, and there again, you want it UL listed, so that's why you have the manufacturer build it as one complete unit. Then they put the UL stamp on it, and it's UL listed.
I never worked in the industry. I worked in commercial. I worked in residential, multifamily. I didn't do hardly anything in controls except screw up a 2-stage thermostat and get fired. I mean, that was almost, yep. pretty much my total control experience. But my perception is that today we're having equipment that really works together better. You're able to buy the contactor. It's already pre-wired. It has the fuses inside there. It has a transformer inside there. You know, you're not having to like make things work. Is that a fair statement compared to maybe what it was 40 years ago, 30 years ago? Or no? Is it similar?
Well, most industry, like our industry, we have some relatively new and some new equipment. And we have some relatively old, like 40 and 50-year-old switchgear.
But is the 40,
And there
50-year-old
is-
switchgear something that people piece together to make things work, and today it's more already built together as a component?
Well, it was built new in 1964,
Okay.
particular ones I'm talking about.
Okay.
And they've been made to last. I mean, we replace what needs to be replaced. If we decide we need a transformer in one, we'll install one that
Okay.
would be correctly sized. And
Okay. All right. Let's talk one thing, because I'm going to forget about the overloads on my boat lift. 3 motors, $1,200 cost me on that. Finally, one day I decided, and by the way, I skied with a barefoot buddy of mine at the time. He was an electrical contractor, and after, we skied for years, and after 3 motors, $1,200, I thought, you know what? Do me a favor, bring me a 30 amp disconnect. Let's go nameplate rated motor. Motor drew, I think 6 amps, little tiny, whatever, quarter horsepower, half horsepower motor, drew 6 amps. He got me a 30 amp disconnect, and he couldn't get me whatever 125% of 6 was, which was 7 amp fuses, or they make a 7 amp fuse, I think, but they just didn't have it in there, or didn't have a 6, whatever it was. He had to get me a fuse that was lower than the nameplate rating of the motor. And I'm thinking, well, put it in there, let's see what happens. If not, we'll just jump it, we're still gonna go skiing, you know what I mean? But put that in there. I think he put like a 4 amp fuse on a motor that drew like 6 amps, because that's all I got. You know that motor worked fine? I was shocked. A 4 amp fuse I could have put on that motor. My buddy was he was a barefooter, an electrical contractor, but even if I hired an electrical contractor, let's say I wasn't, an electrical person, and I paid $200 to put a disconnect with a 4 amp fuse to protect a 6 amp motor, it would have saved the customer, in my case, me, $1,000. And what I learned a lesson was that if you provide overload protection with fuses, we're not talking about a contactor and a starter and all the assembly. We're just talking about a fusible disconnect. And you size the fuses, like you were saying, Dan, you size it at 100% first to see if that's going to work. If you get a fusible disconnect, and let's assume we didn't need any controls at all. I just got a fusible disconnect, and there's a motor right there. Size the fuses at 100% of that nameplate rating. Stick those fuses. If they don't fit in there, get the smaller size fuse, stick it in there. And if your only control is to close the switch for that motor to run, and when you want the motor to stop, just open the switch. That gives you your overload protection. At the same time, that can give you a short circuit and ground fault protection at another level. And that was a lesson that I learned. It's really important to provide overload protection as close to the nameplate rating of that equipment. It really will pay for itself in the long run. We got a slide here, the last slide on this particular DVD. Dennis, tell us about, what you do with this.
Well, these are the simulator boards that I've basically put together, and I've got 2 contactors in them. I've got 3 relay bases that I can put on delays, off delays in, 2 ice cube relays. The keyless fixtures there representing the motors. I have a fuse disconnect or a fuse there to just kind of
Is that a
back
fuse
up.
right there?
Yeah, it's a fuse block
Okay.
right there, which I put in. If somebody shorts something out, then at least it's going to blow the fuse and it's not going to trip the main breaker. On the right side is all the patch cord plug-ins. Then I've got some control lights on the upper right. Then I've got my start-stop stations. I've got a handoff auto. And then I've got 2 toggle switches to represent high-low level switches and that kind of stuff. And the process here, the guys have to troubleshoot where all the patch cord plug-ins go first. They have to find out if they go to the contactors, if they go to the keyless, if they go to the relays, if they go to the start-stop stations.
Is this right here? What are these? Is this?
Those are the patch cord plug-ins,
Okay.
okay? And banana cords is what you want to use there. And so they have to troubleshoot and find out where everything is. So then that way they get an idea of how a piece of equipment actually works and what it does. Then I've got set up ladder diagrams that they can actually physically go through there and hook up, and they can actually see how everything starts to function, like your start-stop station with your magnetic coil and things like that. On the-
Steve, you taught motor control for how many years?
19.
19 years. Did you make up something like this in a lab for yourselves, for your students?
I wish I had a good picture of them. Maybe I can get one tomorrow. But we built up a frame about 4 foot by 2 foot table, and had a steel tube frame and a plexiglass top, so you could see down through it and see the wiring underneath it.
Oh,
And
that's
had,
kind of cool.
Yeah, and then we just drilled holes in the top for all the push buttons and switches and so on in the top, and had a couple motors down underneath, a couple small single-phase motors that they could actually hook up and see them run, and then just pilot lights and things to simulate different activities. And some of them we even had a small PLC on them and put that all together. So I'll have to see if I can get a picture of those. They worked real well.
Well, I think the point is those of you that are instructors and those that go to students, that instructors, maybe you can encourage your instructor to put together something.
Yeah.
And, you know, Dan, what you might put together as an instructor might be different than what Steve is going to put together, because your needs are differently, what you're looking to achieve and what you're looking to communicate, because different parts of the country achieving, looking to achieve different things. Well, we're done at the end of this DVD, but before I close on this particular one, anybody have any parting comments, any one thing that you want these guys to try to remember at this point? Steve?
3-wire controls are simply normally closed stops in series, normally opens in parallel. And you can put any number that you want to. Just get your series and parallel relationships.
Eric?
It may not seem like it, but learning this stuff really does make your life easier. Now, had you learned about all this stuff before your boat lift, you could have saved yourself a lot of trouble. So it may seem to the student at the front end, oh my gosh, this is a lot of work. But the reality of it is that it's more work if you don't learn it. And if you do learn it, you become the go-to guy for your company.
I like that, and I think that's an important point, and that is that you're the go-to guy. You're the person that people have to ask questions. Dan, anything you can just tell the guys for today?
Well, the 3-wire circuit that we've talked about and that you're almost sick of
I am sick.
is basically the building block for hardwired circuits and PLC circuits.
So if I have,
So-
and I think I got 3-wire circuits and mentally 2-wire circuits, I mean, I got it down. Are you saying that that's really going to give me the basic that I need, that when I go to the other stuff, it's going to be fine?
Yes, that's the foundation that you'll build on.
Yes.
Dennis?
Again, go back through the book, go back through the units that we've already covered. And then if you have any further questions, just go back through the DVD itself and re-look at those certain points that you feel that you're still weak on, and I think that'll help quite a bit.
Well, we did it. We did the first part. And it's a building block. We're going to go one more DVD, and we're going to put some of this stuff together now, and garage door openers and some other examples. We're going to talk a little bit about safety. Tomorrow, we're going to just be, putting this whole package together, lockout, tag out, some other important things. Thank you so much. Take a break, do what you got to do, and we'll see you on the next DVD. God bless.